Let me tell you the most interesting thing about string theory is probably not that matter is made up out of these little strings. The most interesting thing is that string theory requires extra dimensions of space. It requires these extra dimensions to be curled up into little dimensions that we can't see, too small to see. But the way that they're curled up, and it's not just that they're curled up, but they can be curled up with strings wrapping around the curled dimensions, other quantities known as fluxes. There's a zillion ways of curling up these extra dimensions.
And those things are here, here, and there, and
right.
everywhere.
Right. And because the properties of space over here are the same as the properties of space over here is the same as the properties of space over here, it means they're curled up the same over here as over here as over here. But as far as we can tell, there's just a zillion different ways to curl them up. Right? Now, I think of these different ways of curling up these microscopic dimensions of space as a kind of DNA, as a kind of DNA of a universe. You could change the way they're curled up. Just like you could change a DNA molecule. You could pull one of the base pairs out and put something else in. Well, you can do exactly the same thing. You'd have a different creature. You'd have a creature with a different set of properties. 3 arms instead of 2 arms. Foot growing out of their head if you didn't do it right. But in the same way, if you change the way these tiny dimensions are curled up, and there are millions of ways of doing it, the structure of the universe will change. What does that mean? Well, it means, for example, that the forces in the universe will change. Gravity may become much stronger or much weaker. Electricity may disappear altogether. It may be a world with no electrons in it. So by changing the DNA that's implicit in string theory, the properties of space at the tiniest distances, you are doing, in a sense, the same thing as when you change the DNA of a creature. You're changing its morphology. In the same way, you would be changing the properties of the universe. So, string theory, among other things, is a theory of the DNA of the universe. That's the way I like to think about it.
But how then are we to understand that this universe is built the way it is? And it's built so that we can exist.
Why is the DNA what it is? Well, I could ask you the same question about yourself. Why is it that your DNA is so? Why were you so lucky that you inherited DNA which allowed you to think and even ask the question, why is my DNA the way it is? Well, the answer is that first of all, there's an enormous number of ways to arrange the DNA. Some very small fraction of them might lead to a creature that's smart enough to ask the question. Most creatures aren't smart enough to ask the question. Some of them will be. You just happen to be one that is. That's all. You just happen to be one.
So it's just
I would say the same about the universe. Probably most versions of this DNA create universes which don't support life. They expand too quickly, or they recollapse in an instant, or they don't have chemistry, or they don't have photons. You need photons to heat you from the sun. Most of them have the wrong properties. Just like most DNA will give rise to creatures that don't have the right properties to ask questions. Most of the DNA of the universe will lead to regions of space which are not the kinds which will support creatures which can ask about it. Some tiny fraction of the way of putting universes together will support life, will support intelligent life, and it shouldn't be any surprise that that's where we are. And physics and cosmology are leaning. I won't say that they've come to the absolute conclusion that that's the way it is, but it's leaning in that direction towards huge diversity, many possibilities of which we are only one.